Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module, next problem number 7, fluid mechanics. Okay, first we come towards statement. A cube 5.0 centimeter on each side is made of a metal alloy. After you drill a cylindrical hole 2.0 centimeter in diameter all the way through and perpendicular to one face, you find that the cube weighs 7.50 Newton. Part A, what is the density of this metal? Part B, what did the cube weigh before you drilled the hole in it? Okay. Density is to be determined and before drilling its weight is to be determined. Okay. Dear students, here 5.0 centimeter, 2.0 centimeter, these two quantities must have to be converted in meter because we are following MKS system. Okay. Now we come toward the solution. Part A, length of each side of cube equal to say L is equal to 5.0 centimeter, which alternatively becomes equal to 0.05 meter. Okay, because we will divide by 100. Centi stands for 100. Centimeter means 100th part of meter. So when we will convert centimeter into meter, from smaller to bigger unit, we will have to divide it by 100. Okay. Now diameter of cylindrical hole, say we denote it by D, is given as 2.0 centimeter and it will be converted into 0.02 meter. Dear students, we are concerned with radius because in formula radius will be used. So we divide diameter by 2 and we will get radius. Radius of cylindrical hole, say R, which is half of the diameter equal to D by 2, is equal to 1.0 centimeter, and when converted into meter it will become 0.01 meter. Now volume of the cube denoted by V is equal to length cube, L cube. Okay, that is to say length is 0.05 meter, so it will become 0.000125 meter cube. Okay. Dear students, this value, that is 0.000125, can be written in several different shapes as per our choice. Okay, but it is not very important. Okay, it is quite meaningless. We can write it as 0.125 into 10 raised to the power of minus 3 meter cube. Similarly, we can write it 1.25 into 10 raised to the power minus 4. Similarly, we can write it 12.5 into 10 raised to the power minus 5 meter cube. Similarly, we can write it as 125 into 10 raised to the power 6, 10 raised to the power minus 6 meter cube. Okay, we do not go in further less important detail. Okay, now volume of cylindrical oval, say we denote it by V dash, is equal to pi r square L. This is the formula for calculating volume. Okay, dear students, we know that formula for calculating volume differs according to different geometrical shapes. Okay, so in our present situation, formula applicable for calculating volume is pi r square L, where r is radius and L is length. Okay, pi, we know that value of pi, which is 22 by 7, is usually taken as 3.14, and we have many times described that decimal representation of pi is non-repeating, non-terminating. It goes endlessly, but we usually restrict our answer only to two decimal places. Okay, so in place of pi we have used 3.14. In place of r, this r, 0.01 meter. Okay, this is this square into L, this L, 0.05 meter. Okay, when these three quantities are multiplied, we get the result 0.00000157 meter cube. Okay, here again the same situation arises, that we can write this figure in several shapes according to our own choice. It can be written as 0.157 into 10 raised to the power minus 4 meter cube. Similarly, it can be written as 1.57 into 10 raised to the power minus 5 meter cube. Similarly, it can be written as 15.7 into 10 raised to the power minus 6 meter cube. Similarly, it can be written as 157 into 10 raised to the power minus 7 meter cube. Okay, it does not make very much difference. It is useless to discuss. Okay, now as per given situation, as per given statement, volume after drilling will be equal to V minus V dash. Okay, and we have already calculated both values. Okay, V is this, V has this value, and V dash has this value. Okay, so we put these two values, this minus this becomes equal to 0.000109 meter cube. Okay, here again that situation arises, that we can write it as 0.1093 into 10 raised to the power minus 3 meter cube. Similarly, we can write it as 1.093 into 10 raised to the power minus 4 meter cube. Similarly, we can write it as 10.93 into 10 raised to the power minus 5 meter cube. Similarly, we can write it as 109.3 into 10 raised to the power minus 6 meter cube. Similarly, we can write it as 1093 into 10 raised to the power minus 7 meter cube. Now, weight W is equal to mg. Okay, from here this implies that mass becomes equal to weight over g, acceleration due to gravity. weight is given in the statement, okay, in the statement, this 7.50 Newton, okay, this 7.50 Newton, 7.50 Newton over G. We know that value of G is a constant. Okay, acceleration due to gravity has constant value 9.8 meter per second square. When we simplify this expression, 7.5, what we here we have done, we have just written kilogram meter per second square in place of Newton, okay, because it is by definition 1 Newton is equal to this, okay, divided by 9.8 meter per second square. Here in this way meter per second square will be cancelled out with meter per second square, and our answer will become in form of kilogram, okay, which is 0.765 kg, okay. So one part of our problem is almost solved, that is weight has become equal to 0.765 kg. Now we know by definition that rho is equal to m over v, mass over volume, okay. Here in place of sign of equality we can also use three lines, which will be read as rho is defined as mass per volume, okay. So here okay, yes, no mistake. I was thinking perhaps I have made some mistake, that I was assuming it as this is W. No, no, this is not equal to W. This is mass. Okay, I have a few seconds or few minutes ago mistakenly said that W has become equal to this. W is not equal to this. M is equal to this. Okay, because W is equal to mg. From here we have taken mass on one side and W over G on other side. So 0.765 kg is not weight, it is mass. So in place of mass we have used this value, and in place of volume we have placed this value, which we have calculated here, okay, 0.000193, 0.000193, okay. By simplifying this expression we get rho, that is density. Density becomes equal to 6999.085 kilogram per meter cube. We can approximately round it as 7,000, okay, but no need for rounding it, it is quite okay. Now we come towards part B, which relates to situation after drilling. Okay. Part B. What did the cube weigh before you drilled the hole in it? Okay, before drilling. It relates to before drilling situation. Okay, so part B, now before drilling, density rho is equal to mass over volume. This implies that density rho we have calculated in previous part A, which is 6,999.085, okay. So in place of density rho we have used this value, and is equal to mass is to yet to be calculated. So we have not disturbed mass. Mass is written in the same way as in previous step. However, in place of volume, we have used this value 0.000125. Okay, this value. Okay, volume of cube V equal to volume of cube V equal to cube of length equal to 0.05 meter cube equal to 0.000125 cubic meter. Okay, so here here in the next step we have kept mass on one side, and this the value in the denominator has been multiplied with this factor. Okay, in this way meter cube will be cancelled out with meter cube, and result will be in kg, kilogram, because mass is always in kilogram in MK system. Okay, so by simplification of this term, that is mass will become equal to 6999.085 multiplied by 0.000125. Okay, a meter cube, and that meter cube will be cancelled out with this meter cube, and mass will become equal to 0.8748852625 kg. Dear students, it is quite sufficient if we restrict our answer to two decimal places, that is 0.87. Okay, it is quite sufficient if we terminate our decimal representation up to two decimal places, that is 0.87 kg. But actually, because dear students, I make calculations on calculator given in the computer, which gives the answer in enough lengthy sense. Okay, and I copy paste that value from calculator on computer into my word file or math type file. Okay, so it is not useless, or it is quite okay even if we write the answer to this extent 1 2 3 4 5 6 7 8 9. Okay, 9 decimal places, this is quite okay. And if we restrict it only to the extent of 0.87, then again it will be quite okay. Okay, next, now weight W is equal to mg is equal to m, this value which we have now calculated, into value of g, acceleration due to gravity, which is a constant value 9.8 meter per second square. After simplifying, we get 8.5738799125 kilogram meter per second square. We know that this quantity is equal to Newton. So weight has become equal to this value into N, that is Newton. This is equal to kilogram meter per second square is equal to Newton. Okay, here again we can restrict our answer only to two decimal places, that is 8.57. But if we continue our answer up to so many digits, then it is quite acceptable. Okay, it is not a mistake. Okay, and this is the end of our module. Now we come towards the reference book from where we have chosen our problem. Reference book is Sears and Zemanski's University Physics with Modern Physics. Its authors are three authors. Okay, Hugh D. Young, Roger A. Friedman, A. Lewis Ford. Its publisher is Pearson, and its 14th edition 2016 or 15th edition 2020 has been adopted or followed. Here chapter number 12 under title Fluid Mechanics is our relevant chapter, and this problem is enumerated as module number 2 of this chapter, that is exercise number 12.2, and this is the end of our module, our problem. Okay.